Okay, we're going to solve problem 1 on practice exam 3. So let's take a look at the question. Alright, so the question has to do with angular and linear speed. So you might want to review the part of the textbook if you're completely unfamiliar with those ideas. And there's a picture here. Maybe you could read the question, but the picture kind of explains things a little bit faster. So you have a fan, and it has 2 short blades and 2 long blades. And it's rotating, you can see there, in a counterclockwise direction, and it has, okay, so what are we given? We're given that, suppose that the linear speed of a point on the end of one of the long blades is 36 inches per second. Alright, so that's like this point here, we're imagining that it's going it's going forward. How much, this is angular, the linear speed is s for arc length over time, right? So it's how much arc length it's tracing out in a given amount of time. Alright, so what do we know? We know that two things. One, angular speed. We use the letter omega to denote angular speed, and that's defined to be radians per unit time. Okay, so angular speed is the arc length per unit time, which depends on the radius, and omega here is the angular speed, which is radians per time, which doesn't have anything to do with the radius, it just has to do with RPMs. So we're given that the linear speed, which we denote by v, for the long blade is equal to 36. Okay, alright, so what are we going to do with that? We're going to answer A here. A is, what is the angular speed of the fan? So this is just asking you, what is omega? Alright, and there's this very handy way to translate back and forth between omega and v. We know that v is equal to r times omega. Alright, so in this situation, what is r? R is the length of the long fan blade, which is 24 inches. Okay, and so let's just write those things down. Okay, so the linear velocity of the long blade, or a point on the end of the long blade, is, on the one hand, it's r times omega, 24 times omega, but on the other hand, the problem tells us that it is 36. Okay, so this lets us solve for omega. Just divide both sides of this equation by 24, and you get that omega is equal to 3/2. Okay, so that is part A. So it's equal to 3/2. And now let's take a look at part B here. It says, what's the linear speed of a point at the end of one of the short blades? Okay, so now we're going to think about what the linear speed is for this guy. And what do we know? Now we know omega, and we also know this radius. Okay, so now I can use the same formula again, except now I'm going to use it for v being the, why does it do crazy things? I'm going to use it for v being the linear velocity of the short thing, right? So short, the linear velocity of a point at the end of the short fan blade is still r times omega. Now r is 12, okay, because the short blade has a shorter radius. And so omega is still omega. So notice that it's right, because these fan blades, the number of revolutions per minute stays the same no matter what the radius is. So the angular speed of the short fan blades is the same as the angular speed of the long fan blades. So the velocity, the linear velocity of the short thing is just 3/2 12, which is 18. Okay, and this would be in inches per second. Alright, excellent. So, and by the way, this would be radians per second, right? Not that we really care so much about the units. And that is the end of this question.